welcome you today at Vivatech on our KPMG keynotes. And I'm very honored to welcome Bruno Maisonnier,
Thank you.
who's the CEO and founder of AnotherBrain, to talk today on our first keynote on pushing technological boundaries when artificial intelligence draws from life. So, as an introduction, let me share with you a few words about biomimicry in technology. So from the invention of Velcro, inspired by bird burrs, to the Shinkansen trains, inspired by the beak of the kingfisher, natural processes from the living world have long been a key source of inspirations for innovators in the creation of new products, services, and processes. The concept of biomimicry is based on the idea that nature, after billions of years of evolution, is best equipped to solve the particular challenges and optimization issues we face in technological development. And now let's talk about AI and biomimicry. The living also inspires the development of AI. For example, artificial neural networks have been directly inspired by the human brain to learn and make decisions. However, new advancements in this field go even further and strive to reproduce not only the structure, but also the dynamics of the brain. So I have the pleasure to welcome Bruno to talk about this topic. Bruno is a graduate from Polytechnique and Telecom Paris, and he founded, prior to AnotherBrain, he founded Albane Robotics and turned it into a world leader with Now and Pepper, the two famous robots. He founded AnotherBrain further to that experience in 2017, which aims to create chips of artificial intelligence, or better, real intelligence. So Bruno, my first question for you is, prior to founding AnotherBrain, share with us a few words about your experience, your entrepreneurial experience from Aldebaran to AnotherBrain.
Thank you,
And
Albane.
how you came maybe to the idea of developing AnotherBrain.
Thank you, Albane. Thanks to be here, all of you. I'm very honored to have you, so many people here to try listening to what I'm saying. In my previous life, I created Aldebaran Robotics, the robots, humanoid robots, Now and Pepper. Some of you may know them. Okay, and those robots are great, but they are very frustrating because immediately when you begin to interact with those robots, you understand that they are just automaton programmed. So they are doing what they have been programmed for. They are not understanding the surroundings, what's happening around. So at that time, I began working on trying to give them some kind of ideas about what is around, surrounding, and so on, which means AI. And the question is, the real world is really tough. The real world is real. If you are falling down, then you are falling down. The physics is here, the gravity is here. So you have to understand this real world to make the robots able to understand. And that's not easy at all. For instance, if you had a robot here, the first thing that somebody is doing in front of a humanoid robot is, hey, hello robot, waving hands to try interacting with the robots. But if the robot was here, then you would have 10 people doing the same. The robot will never understand what's happening, so never will be able to react properly. So we needed to have an intelligence that allows the robot to understand the real world. And this is not at all what deep learning and all the neural network intelligence are able to do. Deep learning is powerful, great, amazing, but it's only doing statistics, categorization. So you have to give a list of the different possible situations, and the system is able to tell you, we are in this situation. It's more or less how it's working. But when you are in an open world, you want to have a system acting in a real open world where the situations are innumerous, like self-driving cars or like robots, then it's not possible. You absolutely need to have a real intelligence to be able to react properly. So that's why till 4 years ago, everybody was telling us that self-driving cars is for tomorrow. It will come very soon. Now, nobody is telling that anymore because everybody understood that deep learning, that means the mainstream AI, will never get to self-driving cars. We have to invent a new way of doing intelligence, artificial intelligence. And here, my company is betting on the fact that if we're trying to replicate how the brain is working, maybe do we have something that will give us some hints of how to do. So this is why we entered in this field of bio-inspiration. I'm not saying biomimicry. The goal for me is not to do the same way as nature, but to be inspired by how nature is doing. So this is was this first question.
Yeah, so my second question is related to organic AI. How does it differ? Well, you started to explain it, but maybe go a bit further. And how does it differ from conventional artificial intelligence? And why you think we should aim to draw more inspiration from the living to innovate?
The question behind that, and then I will address the point, is what do we know about how the brain is working? That means there are a lot of preconceived ideas that the brain is something very difficult to understand. It's a very complex machinery. It's very, very complex system. But nature is not able to do complex things. Nature is very, very good at optimization. Step by step, improving something, which means optimizing things. But nature has never invented the wheel, for instance. That means nature is not the great thing that is doing everything better than anything else. Nature has not invented the wheel. So that means nature is not able to do everything. Nature is very good at optimizing. And if you look at the brain, more or less the power consumption of the brain is 20 watts. But here, 80% of the brain is here to handle infrastructure of the body. The intelligence part, the cognitive part, is just 20% of the neuron of the brain. The cognitive part, the cortex, is 20%, even less, of the neurons of the brain. So that means the intelligence in the brain is consuming something like 5 watts. But if you compare that with what we are beginning to get with ChatGPT and all the other systems, that means you need a nuclear power plant to make ChatGPT working. So we are in another situation. The basis is totally different. So one thing is doing categorization, and it's a huge CPU power needed to make that. And you have to train on billions of data, and we all know that. So it's bringing us some constraints on the kind of data. But when you look at the nature, 5 watts altogether to be able to make decisions which are not always the good one and the best one, but that are appropriate in a situation that could be a totally brand new situation. So that's why we are getting inspired by the brain. And we know many things on the brain. Do we know everything? No, at all. Of course, not at all. But it's not because we don't know everything that we know nothing. We know a lot of things on the brain. And the question now is more how to put together all these things in a framework more than to invent new things. We know a lot of things about how the brain is working. And I think we know far enough to be able to reproduce something working like the brain is working.
So could you tell us a bit more about the 2 main solutions or projects you're working at with AnotherBrain?
AnotherBrain is a company that I founded in 2017, as you said, and we are working on 2 pillars. One pillar is this organic AI, artificial intelligence inspired by the brain, so that means real intelligence, and we are going to do that under a chip. So it will be a chip working like the brain, small chip if we want to have small intelligence to have, for instance, a vacuum cleaner robot working correctly or a drone flying properly. But if we want to have something much more smarter, much more intelligent, like a self-driving car, then we will need to have a larger chip. But it's a question of the size of the chip. So it's one thing we are doing, organic AI. And besides that, we are doing something different, using the technology we discovered. So we don't have this organic AI finished, but we have part of that, using this part to create a solution, a product. And we are addressing the quality control, inspection on production lines, visual inspection, and we tried with a sonar sound inspection, which is bringing us some new differences, something new. So we have a solution for making smart inspection, visual inspection, and it has been benchmarked by people like Valeo, like Renault, like other companies. It has been benchmarked, and our solution is better than all the competitors on the market for this visual inspection, detecting if there is a default on a product at the end of production line. So we have these two products, two pillars of the company.
Thank you. And more broadly, we can see that technology is getting an integral part of our lives. What do you think on how we could better leverage it to help us in the huge transitions that we need to face as companies?
There are many, many topics behind that. First one, I would say that for me, there are huge challenges we know for decades and that humanity is not able to solve because it's far too complex. I'm thinking to two things. First, genetic engineering. That means we have many children, people, no children in the families that have illnesses, DNA deletion, and it's 50 years that everybody is telling us, no, it's coming, genetic engineering will solve that and so on. But it's 50 years and nothing has been solved. So I'm touched by this question personally, so I know what it means. That means you are waiting and waiting. Why? Because it's so complex to solve that. So if we could bring artificial intelligence without limit, bringing intelligence to address these very difficult problems, maybe could we have some help? And the other one, of course, is climate change. So for me, everybody knows the problem we are facing altogether. So it's not a question of informed people. They are already informed. Trump is perfectly aware that but everybody is aware of the problems. The question is we don't know how to solve that. Because if we are solving, either it will cost too much for people accepting that, or we don't have solution. So if we could bring real intelligence without any limit to help solving the problem humankind is facing, I would be happy. And I think we can do that. I think technology will bring that.
When we discussed prior to today, we also came to discuss about the ethical challenges that are brought with artificial intelligence, in addition to the huge potential generated by AI. So what's your view on this?
I will answer you, but I will answer another question you didn't put. How it's working, organic AI, because I think it's important to understand how it's working. But about ethics, it's a major subject, so I will make a summary. It's a very major subject, but I don't care. It's not I don't care. I care deeply, but I think it's far too early. That means if we had put in the early 90s, if we had put all the rules, regulations on the car industry or plane industry that we have today, we would have killed these industries. That means the nature is doing what? The nature is doing Darwinian exploration of solutions. So let's have this Darwinian exploration phase of the AI that will help us discovering possibilities we don't even think about, and then we will be able to regulate. But afterwards, first, let's think happening, exploring, discovering great things, because if we regulate too early, we will cut positive opportunities and positive outcomes too. So if we want to take the positive outcomes from that, we have to leave some space. So don't go too fast on regulating. So now if I'm finishing about the other question, how it's working, that means there is something you need to understand to give you some hint. The neurons we have in our brain are working more or less at 1 millisecond. If we are to make a decision, for instance, you are driving, something is happening, you have to brake immediately, it takes you 0.1 second. That means it takes you 100 neurons in a row. It takes the brain 100 neurons. So somebody knows how to program? What can you do with a 100-step program? 100, so you can do nothing. You cannot even print something on your screen, put a character, 100 steps, no more. That means the brain is not computing anything. The brain is not computing. The brain is kind of a memory. Yes, the brain is kind of a memory. It has recorded a lot of sequence of patterns, let's say, sequence of patterns. And what it's doing is just hearing what is happening, seeing what is happening, and getting in its memory to discover which sequence of patterns do we have, and then comparing. And then if it discovers, oh, I already had this sequence of pattern in my brain, so this is what happened after, so it can recall what is going after, and then doing prediction. So the brain is kind of a predicting memory. So it's a memory doing prediction. And it's not calculating and computing. So that's why everything computing will never do an AI working like the brain.
Thank you, Bruno. And one question more related to AnotherBrain to conclude. What are your immediate next steps as AnotherBrain? And what are you really, as a wish, what is your wish, if you shall have one?
Two things. I really want the industry to be improved by this system of quality control, because industry needs quality control, but it's something which is done manually now. That means it costs it's a lot, very expensive part of the costs. So if we want to bring back industry in our developed country, then we need to reduce these costs. So here we have a solution, and my next step is to be able, people on the industry market, to understand and to discover it and then to buy it, of course. And the second one is our organic AI. The next step is to produce an FPGA. It's a programmable chip, but a chip that will demonstrate the power of what we have. And I expect in 2024 to already have a chip that will demonstrate the power of our organic AI, and that we are on the right path.
Well, thank you very much,
Thank
Bruno,
you,
and we look forward to the success of AnotherBrain.
Thank you.
Maybe there are some questions? Do you have any questions?
We have time for that, so if you have questions, please go ahead.
Ernest from BNP Paribas. I had a question about the organic AI. Why not doing it really organically? Is it possible?
Is it possible to do organic AI? I don't know. I'm not trying. I don't want to try. My goal is not to do the same way as nature. Nature is doing a lot of things in the brain in parallel. We have 200 millions of cortical columns in parallel. Very difficult to do that. But what we are doing is using the speed of electronics to do what we are calling multiplexing. That means we create one column, and this column is working at the speed of electronic 1 million times faster than the brain. So then it's behaving as if it was each of these columns separately and then reconstituting. So I don't know if I would be able to do that organically.
Hi, I'm Louis Delois from ENS, a PhD MBA. I'm kind of curious if you looked into doing it with other things other than electrical, maybe photonics, because it's integrated, right? You want to make a chip. Did you think of other supports, let's say?
Why not? It's a possibility. It's the physical implementation of this chip. I think I don't really care whether it's on photonic or electronic or other ways. So it's probably possible.
Thank you for this overview. Mariana from EdgeLab. Interesting presentation. In my previous life, I used to be a molecular biologist. Now I'm having an AI company. But I was curious about the practical applications. So what's your plan regarding the first, maybe multiple ways to put this into solving real-world problems and putting it into the market?
The first application will be in smart perception. I don't know whether you tried these robotics vacuum cleaners. But if somebody tried them, it's great. They are vacuum cleaning without you. But one every 3 days, when you are getting back home, they are trapped on the wire of your halogen lamp or on the foot of your table. So why are they trapped? Because they are not able to understand that there is this kind of thing. But we could bring them with very, very few intelligence. It has to be a real one because they are all different, your table, foot, and so on. But it's very easy to bring with a real intelligence that will boost that. The market is 20 million already, robotics vacuum cleaner, so it's a market. Then we can do the same with drones. If you are doing bicycles, then you take your mountain bike, you go on an hill, and you throw your drone away, and you tell him to take a movie on you getting down the mountain. But as soon as you are going behind a rock, behind trees, then the drone is losing you. So it's not operational. But you can bring them with small intelligence. You don't need to put a lot of intelligence to make them understanding that if you came here, you have to go out somewhere. So, you know, we have different applications that will, from very easy things up to self-driving cars. But then we have been contacted by French space defense of French or by other things to have systems able to react to new situations they have never seen. So we have a full range of applications from small intelligence to larger intelligence.
Thank you.
Maybe one last question?
Last question.
Thank you. And the first question is that, do you think it's necessary to make AI much more similar to the human brain?
First, I'm not speaking of human brain, but natural brains. Because a dog brain is smaller, but it's working the very same way, and a mouse and a very same. So natural brains. It's not needed to do the same way. What I know is we need to have real intelligence able to make decisions on situations they have never seen, and we have kind of a reference. So we can get inputs from this reference. So that's why I'm looking for that. But if I had inputs of something totally different, why not? So my goal is not to do the same than human brain, but it's a good reference to do a real intelligence.
Thank you very much.
Thank you so much.
Bruno.